Determine whether the following telescoping series converges or diverges. So they're giving us a hint as to an approach to use for convergence or divergence. They're telling us the series is telescoping, so the sequence we're adding up, ln of n over n plus 1, must be telescoping. So what does that mean? Okay. Our ANs are ln n over n plus 1. We need to find a way to write them as Bn, a difference of Bn minus Bn plus D for some other sequence of Bn's and some value D. Okay, so how can we write the ANs as a difference? And we can play around with it for a fair bit. Okay. We realize we've got ln of a difference, or a division in here, and that can turn into a difference of lns. Right, so when you line it up like this, it's really asking for Bn and Bn plus 1. So Bn is ln n, and our D here is 1, the most common D of them all. Okay, so great. I found this other B sequence. I found D. This really is a telescoping sequence. How does that help us? Well, a telescoping series converges if and only if the limit of a sum of D consecutive terms in the B sequence exists, if that limit converges to a value. Now, since D is 1, we just need to ask, does the limit of the BNs exist? We don't care what it is, if it's 5, if it's negative pi million or something like that. We don't care. Just does it exist? Okay, so that's the crucial question here. So that's going to be the limit of ln. But hold on. If I plug in bigger and bigger numbers into ln, okay, that just goes off to infinity. So the limit here does not exist. Remember, saying limit equals infinity is just a very special case of does not exist. Okay. But since the limit of the BNs doesn't exist, then that means the series cannot converge. Okay. So our telescoping series diverges. And there we go. So what did we have to do? We had to recognize our ANs as a difference, Bn minus Bn plus D, figuring out the Bn's and the D's, and then we had to take a limit. Okay, the limit didn't exist, so the series diverged.